Welcome to our video on translating verbal expressions into variable expressions. This is a very important skill. It basically means, can you take some English and translate it into math, right? We need to be able to read these pesky word problems that everybody fears and translate them into expressions and equations in algebra so that we can eventually solve them. So here are our three objectives. We want to translate a verbal expression given the variable. We want to translate a verbal expression and then simplify. And then we want to be able to translate application problems. That's the biggie, right? It's going to culminate in part C. So let's start with the easy ones given the variable. Okay, so one of the major skills required in being able to work with mathematics is the ability to translate a verbal expression into a variable expression. You have to be able to take English and translate into math. And there are some very simple, common things. Like there's signposts. It's almost like having a little math to English dictionary or a English to math dictionary. There are certain words that always translate to the same kind of mathematical things. So once you learn those, you can pick them out of, sentences, and it helps guide you into the correct algebraic expression or equation. For instance, how do you translate something as simple as 14 less than the cube of x into a variable expression? Well, less than is the key. Anytime you see less than, you know you're doing subtraction. However, here's where it gets a little tricky. When you see is less than, is always implies equals, right? So when you put that is on there, it means it's equal to being less than, and then all of a sudden you get the less than symbol, right? You'd have 14 less than the cube of x would be written as 14 less than, right? That would be is less than. But we don't have is here, we have just less than. So that's when we do just subtraction. All right, some more keywords. When you see the sum of something, that's always addition. The difference between two things, that's always subtraction. The product of something always means multiplication, and the quotient of something always means division. Here's an example. The total of 3 times n and 5. Well, the total of 3 times n and 5 is 3n plus 5, right? The and 5 always means addition. Okay, so here's a table of some of the kind of more common words or phrases that you're going to see. I would suggest, putting these in your notes. If you haven't downloaded the PowerPoint, then take a picture or write it down or whatever you got to do. But until you start to memorize these things, right, it's like learning a foreign language. This is your translation. Added to, more than, the sum of, increased by, the total of something and something, plus. Those are all simple words that mean addition. And then you've got minus, less than, less, subtracted from, so on and so forth. Those all mean subtraction. Simple. Words or phrases for multiplication, right? Times of, product of, so on and so forth. Division, divided by, quotient, ratio. Powers, they'll just say the square of, the cube of. You can go on and on and on, but usually square and cube are the only two. When we talk about powers that are 4 and above, you normally will see the word power, right? To the 4th power, to the 5th power. We don't have special words that we usually use for anything above cube. Okay, so let's look at some more examples where we're going to try and translate phrases. We have to assign a variable, right? They don't give us a variable all the time. And then be able to kind of solve them or reduce them later on. So how about a number, right? We want to translate the phrase a number multiplied by the total of 6 and the cube of the number. So you see how they say a number and the number? That's implied then that we're talking about the same number, which means we're going to use the same variable. Now here I used n. You don't have to use n. You could have used x. You could have used y, z, a, any variable you wanted, as long as they were the same throughout, right? Because the unknown number here, the thing that we don't know, is n. And that's always one of the first keys whenever you're dealing with word problems and translations is you always need to identify the variable. What's the variable? Did they give you a name for the variable? And if they don't, then you have to assign one, right? So what's the unknown? What's the thing we don't know? And in this case, we don't know the number that's doing all this stuff, multiplying and blah, 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 blah. So that's our unknown. That's our variable. We're going to give it a name. We're going to call it n this time. You can call it whatever you want, x, whatever. So the cube of that number is now going to be n cubed. And then now we have to just do a number multiplied by the total of 6 and the cube of that number. Well, the total of 6 and the cube of that number, total of, remember, means addition, so we're going to go 6 plus n cubed, and then we're going to multiply that by n, so that's where we get n times the quantity 6 plus n cubed. All right, hopefully this is seeming kind of easy to you guys because it's just a matter of translating each bit and piece of the sentence. A number added to the product of 4 and the square of a number. Again, we don't know what the number is, so we're just going to call it something, right? We can call, okay, a number, that's going to be n. It's going to be added to something. And it's going to be the product of something. So we're going to be multiplying something. What's that something we're going to be multiplying? Well, we're going to be multiplying 4 and the square of a number. Well, and gives me this, right? 4 is this. The square of the number, that's n squared. So now let's put it all together. A number added to the product of 4 and the square. Uh-oh, it's the product of something, so we're not going to be doing addition. We're just going to be doing the product of 4 and, right? So and is not always going to be addition because we're talking about the product. This whole thing comes as one phrase. The product of 4 and the square of a number, that's 4n squared. And then that is going to be added to the number we don't have, right? That we don't know. Okay. How about some applications? Most applications in math are going to require that you identify the unknown quantity, assign it a variable, and then somehow figure out how to express these unknown quantities in terms of that variable. So here's a simple example. The height of a triangle is 10 feet longer than the base of the triangle. Express the height of the triangle in terms of the base of the triangle. Well, we don't know either of them, so we give them an unknown. We call the base b, and since the height is 10 feet longer, it's just b plus 10. It's that simple, right? And this is a simple example. They can get more difficult, but that's the idea. The length of a swimming pool is 4 feet less than 2 times the width. 4 feet less than, right? So we're going to subtract 4 from something, 2 times the width. So here we have 2 times the width minus 4. Now, here's a tip that I always suggest to students. When you start translating these things that get a little bit more complicated, like the first one was pretty easy. Okay, it's 10 feet more. Duh, that's just plus 10. This one might seem a little bit more complicated. Is it going to be 2w minus 4, or is it going to be 4 minus 2w, right? Because it's 4 feet less than 2 times the width. And especially for any of you that maybe English isn't your first language, that's a really easy mistake to make and think that it should have been 4 less than, right, 2 times the width. That's kind of if you just did a straight word-for-word translation. What I suggest is, okay, plug in a simple number and see if it makes sense. All right, let's say the width equals 10. Simple, easy number. Now, translate this in your head. So the length is 4 feet less than 2 times the width. Well, if I put 10 in here, I get 4 minus 2 times 10, which gives me 4 minus 20, which is negative 16, which right off the bat should tell you something's wrong because how can I have a negative length, right? So then you come down here and you go, well, this is 20 minus 4, which is 16. Is 16 4 feet less than twice the width? Yes, because twice the width would be 20. 20 minus 4, right? 4 feet less, that would be 16. So when you put it back in the context and actually use numbers and think about it, okay, so now I'm going to let this thing actually be 10 feet wide. Now, according to the description, how long would my pool be? And do the math and make sure it makes sense. That's a great way to check your work and make sure that you haven't made any mistakes. All right, hope this helps.